I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, I'm going to do a few numerical examples on the frequency of rotor current of induction motor. So, in the previous session, I have discussed about the derivation of frequency of rotor current. So that means F dash, that is nothing but frequency of rotor current. That is nothing but the product of slip and supply frequency. That means F dash is equal to SF. Correct. That formula you have to remember. Yes. Now I'll be showing you the new problem. Let me share my screen. So we'll complete the numerical example quickly. Just a moment. So you can read the question first of all. Yeah. A three-phase induction motor has 6 number of poles. So P is equal to 6 and runs at 960 RPM on full load. So the speed of the induction motor, that means speed of the rotor, that is given by 960 RPM. It is supplied from an alternator. So we have alternator. Okay. So we have alternator. Alternator is supplied to three-phase induction motor. So I'll be writing like a IM, induction motor. So the alternator will have, I'm talking about alternator. Alternator will have four number of poles and the speed of alternator is 1500 RPM. So frequency of frequency is already given. Sorry. So poles, number of poles is not a frequency. The number of poles of an alternator is equal to 4. Speed is equal to 1500 RPM. Therefore, frequency or supply frequency we can calculate. Fs equal to F, that is equal to Pn divided by 120. That is actually the frequency of alternator. That means we can identify the supply frequency. What is number of poles of alternator? 4. That should be multiplied with the speed of alternator. 1500 RPM divided by 120. So please simplify. So here it becomes 3 times. That means 5. So therefore it is very clear that the supply frequency of alternator, the alternator is giving the power at a supply frequency of 50 Hertz. So I'll be denoting the frequency is equal to 50 Hertz. Okay, so here you can note down the frequency is equal to 50 Hertz. Understood now? Yes. Calculate the full load slip and the frequency of rotor current. So first we will calculate the full load slip. Okay, so before calculating the full load slip of induction motor, we have to calculate synchronous speed. What is synchronous speed? 120 F divided by P. So 120 into the supply frequency. We already computed from the alternator, that is equal to 50 divided by number of poles of induction motor is equal to 6. So here you can simplify 2. So that means 1000 RPM. Hope it is clear to everybody. 1000 RPM. Please verify. Okay. So now I'll be continuing. We'll be computing the slip. The slip is nothing but ns minus n divided by ns into 100%. You can do it. What is ns? 1000 RPM divided by what is n? 960 RPM divided by 1000 RPM. Okay, write properly. So what could be the answer? So answer you have to estimate. So let me verify. So I have already calculated and I'm going to verify. So how much you are getting, you can check it up. So yes, it is. You are getting like a 0.04. In terms of percentage, slip in percentage, I'll be writing 4%. It is 4%. So we have received the value of slip. Now I need to calculate slip is done, load slip, and the frequency of rotor current. So frequency of rotor current is equal to F dash, that is equal to S into F. So S is nothing but 0.04. The supply frequency is 50 Hertz. Please calculate. I'm also using the calculator. So I should get 2 Hertz. 2 Hertz. So ultimately the answers are the slip is 4% and the frequency of rotor current is 2 Hertz. Okay. So let me move on to the next problem. I would like to discuss another problem. Yeah. Request you to go through the problem first. A frequency of voltage applied to 4-pole induction motor. So P is equal to 4. Then supply frequency is how much? 50 hertz. That of the rotor induced EMF is 1.5 hertz. So F dash is equal to how much? 1.5 hertz. Frequency of rotor current. So what is the value of slip? Slip I want to calculate. And what is the speed of the motor? Rotor speed also I want to calculate. You already know that F dash is equal to S into F. F dash equal to S into F. So from this I can calculate slip. That means F dash upon F. F dash is how much? 1.5. What is supply frequency? Supply frequency is 50. Kindly use the calci and compute. How much you are getting, you can calculate. Yes, I'm getting 0.03. Please do verify the answer. So now I want to calculate the speed of motor. That means rotor speed. You already know that slip is given by ns minus n divided by ns. So slip value is 0.03. So ns is nothing but, how to calculate ns? Ns is nothing but 120 f by p. So 120 into supply frequency I already have 50. P is nothing but 4. It becomes 3. So that is equal to 1500 RPM, 1 revolution per minute. So 1500 minus, I don't know the value of rotor speed. I have to calculate, divided by 1500. So simplified 0.03 into cross multiplication, that is equal to 1500 minus n. Therefore, n is given by 1500 minus 0.03 into 1500. Kindly simplify. I am also using the calci. So I should get 1455. Yes, that is the answer which I am getting. Kindly verify and use the comment box to review the answer. So thank you so much for watching this video. Here I discussed about the problems related to frequency of rotor current. Happy learning. Have a great day. If you are watching our channel first time, I request you to subscribe. Also kindly share the people, those who are working in this domain. Thank you all. Happy learning.